पॉइंट नजर आ रहा है सबको? Hello? You're recording. This is recording, but can everyone see the PowerPoint?
Yes, ma'am.
Okay. We will start at 3 o'clock. It's 2:59. Okay, it's 3 o'clock. I hope that students are here. There are not so many students so far. 1, 2, 3, 4, 5 students. But it's 3 o'clock, so we have to start. So last time what we were doing, this is recording, right? Yeah, last time we were doing, we had started special relativity, and last time we were doing time, we derived the formula for time dilation and for length contraction. Are there any questions related to those? Time dilation, length contraction? No? Okay, then today we're going to derive relativistic momentum and relativistic energy and the relation between relativistic energy and relativistic momentum. Okay? So as I said before, classical momentum was given by what formula? Momentum is equals to mv, right? That's classical momentum. And in the relativistic case, like if I write on the whiteboard, if I write here, you can all see this, right? What I'm writing?
Yes, ma'am.
Classical momentum is equals to mv, and the relativistic momentum is equals to gamma mv, and that's what we're going to derive, gamma mv. And we want to derive this formula. So how are we going to derive this formula? Let's see. We need another situation. Basically, what I said before is that gamma is what's the formula for gamma? 1 over square root 1 minus v square over c square, right? So if this is the relativistic momentum, in the classical limit, it should go back to this formula, right? We want to see in the classical limit, v is much less than c in the classical limit, right? So if you put here v is much less than c, that term will go to 0. This will be negligible, so it will go to 0, and then we will have 1 over squared 1, which is 1. So basically, gamma will be 1. So relativistic gamma mv goes back to the classical limit, goes back to the classical case. So this is the limit that from relativity we will go to classical physics, to classical momentum. From relativistic momentum, when we apply v is much less than c into this formula, we will go back to our classical momentum formula. So now what we want to do is we want to derive this formula. How are we going to derive this formula? We need to envision another situation. Like time dilation and length contraction, the way we were deriving those is that we envision a situation. We have a vision of a situation, and then based on the situation, we do the calculations, and when we do the calculations, we're able to reach the derivation. So basically now, let's consider a situation. Now what we're doing is that we're trying to derive the formula for relativistic momentum, and then we will derive the formula for relativistic energy, and then we're going to relate those two together. There's a formula that relates energy to the momentum in the relativistic case. So we will do that as well. So let's consider a situation where there are two particles A and B, and there's a collision between them, in which the kinetic energy is conserved. You know what the difference between elastic collisions are. You must have studied momentum in classical physics. So there are different types of collisions. There's elastic collision, inelastic collision, completely inelastic collision, etc. So elastic collision में kinetic energy, total kinetic energy is conserved. That's the definition of elastic collision. Total energy is always conserved in any total energy is always conserved. But elastic collision में kinetic energy will also be conserved. So now we have two particles A and B. So we have two reference frames. One is S and one is S dash. S dash is moving towards the right with a velocity of v in the x dash direction. Okay, so the frames S and S dash are in uniform relative motion relative to each other, in the sense that if this is at rest, then this is moving towards the right side with velocity v. So the relative velocity between these two frames is the velocity of v in the direction x dash, in the direction x. Both x and x dash are parallel to each other, so we can say that it's velocity v. This frame S dash is moving with velocity v in the x direction, or x dash direction. So now what we want to do is they both A and B are going to collide. They both, like, A is moving with upwards with velocity v sub A, VA, and B is moving downwards with the velocity v dash B. Okay? So basically A is in this frame S, and B is in this frame S dash. So collision, now if you want to envision the situation, they both are going to go down and collide. Does that make sense? Is there any confusion related to the situation? So basically, if there's a collision as seen from frame S, A is in frame S and B is in this frame. So A as seen from frame S, A is moving up, and then it will, after the collision, it will move down, but B is in this frame. So because the frame is moving in this direction, B is going to move like this. It's going to be apparently will move like this and like this. I hope that makes sense. Because we're observing from frame S, A is in frame S, and B is in frame S dash. So A, as seen from S frame, is going to move upward, and then after the collision, it will move down, like upward and then down. But because B, we're seeing the situation from frame S, and B is in frame S dash, which is moving towards the right with the velocity V, therefore B is going to appear to move in this path, along this path. Now, does that make sense so far? The situation? Hello?
Yes, ma'am.
Okay, and then we have a situation where if we are in frame, now we're viewing from frame S dash. So there are two situations. We can view the collision from frame S, this frame, or we can view from this frame. If we view from frame S, then we see a situation like this, that A is moving up and then down because A is in frame S. So A is not going to be affected, except that it will just move up, and like it's moving up and then it will move down after it collides from B. So the path of A will just be up and down, because that frame is not moving relative to A is not moving sideways, left or right, relative to the observer, because we are observing from frame S. Now, if we consider a situation where we are observing from frame S dash, how is it going to appear? B is not going to change. I mean, B will just move down and then back up. It's not going to move left or right. Why? Because we are in the same frame as B. We are in the same frame as B, and if we are looking from frame S dash, then because the frame is moving towards the right and A is in S, so A is going to appear to move backwards, right? Like this, up, up and towards the left, and then down towards the left. Any questions so far? I hope this configuration, everyone is understanding the situation here. Okay. Okay, so before the collision, particle A was at rest, yeah? And particle A before the collision, अभी collide नहीं हुआ. Particle A was at rest in frame S, ठीक है? अगर हम इसको draw करें, so particle A is here, ठीक है? And particle B is here. This is B and this is A. They both are at rest initially. And then what happened is that at the same instant, A is thrown upwards in the positive y direction with speed VA, while B is thrown in the minus y direction at the speed VB dash. So this is thrown upwards. This is the positive y direction. This is the positive y direction. ठीक है? So this is thrown with the velocity v a, ठीक है, and this is thrown downwards with the velocity v b dash. Why am I calling it v b dash? Because v b dash, because b is in frame s dash. We're observing b from frame s dash. But a we're observing from frame s. And this frame is moving towards the right with velocity v. So as seen from frame S dash, A will move up like this, but B will move like this and then like this. Yeah? Because we're observing from this frame, and if this is going up and then down, this frame is not moving, but this frame is moving. This frame is moving towards the right with velocity v. So it's going to go like this and then like this. Similarly, as we talked about in the time dilation when we were doing one of the previous examples and we had a situation like that. But then as viewed from, if we view from this frame, if we view from S dash frame, this is the view from S frame. View, ठीक है, from S dash frame. S frame, this is the view from S frame. And from S dash frame, we will get a situation that B is moving downwards and then upwards. B is going to move like this. ठीक है? And then we have A is moving like this and like this. Okay, so now let's try to analyze this situation. Let's try to do some calculations. Now we're saying that VA is the speed of velocity of A in S frame, and VB dash is the velocity of B in its own frame. We call it VB dash because S dash is the frame in which B is in. Okay, so both the velocities are equal. For elastic collision, they will rebound with the same velocity. Okay. So behavior of A is exactly the same as the behavior of B. The behavior of A as seen from S is exactly the same as the behavior of B as seen from S dash. As seen from S dash. So as seen from S dash, we see the situation that A will be going backwards like this. And then as seen from S, we will see that A is going up and B is going like this. Okay, so now when the two, what happens after the particles collide? A rebounds in the minus y direction. A rebounds in the minus y direction. Which frame are we talking about? Okay, so basically what's happening now is that we want to define T0. T0, before we do that, we will say that y is equals to half of y. If the particles are thrown from position y apart, the observer, yeah, so if this is the distance, this is the distance y is the initial, capital Y is the initial distance between the particles, okay, capital Y. And for A to move, what is this distance? This will be half y divided by 2, right? Capital Y divided by 2. We call this small y. Why am I saying this? Because this is an elastic collision. Both of their masses are, what can we say about the situation? We say the situation is that what we're saying is that they collide at exactly the midpoint between the two particles. They have exactly the same speeds initially. So they will collide at a point on the midway between the two particles. And what is the round trip time T naught for A as measured from frame S? So as measured from frame S, which is this frame, the round trip time for A, which is the proper time. Why am I calling it T naught? The time will be T naught for this frame, proper time, and it will be T for this frame. Why am I saying it like that? Because remember when we did the example for time dilation, we said that the proper time is denoted by T0 in the frame if the observer is in the same frame which is not moving. And if the observer is in the frame that is moving, then the time will be dilated. Yes? If we see an event, if we see the event over here, an event that takes place in this frame, the time will be dilated. Is that making sense? So T0 is equals to y divided by VA. So our distance here.
Excuse me, can you repeat that? The time dilation thing?
Yeah, okay, let me just say that the round trip time TA for A as measured in frame S. As measured in frame S, what is the round trip time for A? This is y by 2 and this is y by 2. So total distance, total time will be y divided by its velocity. Yes? Y divided by VA. This is the time taken for A to move from here to here in frame as seen from frame S. Does that make sense? But on the other hand, we will, what about if we are observing the time for B to move in from frame S dash? I know this is a bit like difficult to understand, but if you are in this frame, if your observer is in this frame, okay? This frame sees, observer in this frame is going to see a situation, observer in this frame is going to see a situation like this, where A is going to move up and then down without any motion in the left-right direction, but B is going to be moving like this, and like this. So what is the round trip time for A? That will be T0, the proper time, is equals to, this is y divided by 2, this distance, because I said that the total distance between from here to here is y, and they collide at the midpoint, right? So what will this distance be? Y divided by 2. Yeah? Y divided by 2. So if it goes up, it will travel y divided by 2 distance. If it goes down, it will travel y divided by 2. But the total time will be twice, because it's going up and then going down into y divided by 2 divided by speed, distance, time is equals distance divided by the velocity. Yes? So this equation should make sense. So basically 2 cancel. So we will get y divided by velocity of A. Does this make sense? This is as seen from frame S, as seen from S. And T0 is defined as the time, T0 is defined as the time, round trip time for A to move this distance, for A to move from here to back to the, from here to here to reach here, in as seen from frame S. Does that make sense? No? I think, I don't know, like these topics are very, like, you have to understand what's actually happening in the situation. So once you understand what's happening, then you'll be able to do the mathematics in this. So any questions? Tell me what's confusing you. You have to think about the reference frames and where the observer is relative to the particles. Does this make sense? समझ में आ रही है? Okay, now if we are observing from, now if the observer is in this frame, now I'll use blue pen. If the observer is in frame S dash, as seen from S dash, B is going to move down and then up, but A is going to be appearing to move not in this direction, but backwards. Not in this direction, but in this direction. Because as seen from, if there's an observer in this frame, the frame is moving in this direction. The frame is moving in this direction. So the observer who's in this frame, the frame is moving in this direction relative to this frame. Relative to this frame. So this frame, an observer in this frame will see B moving down and up, but A is going to be appearing to move like this and like this backwards, because this is moving forward relative to this frame. I hope this is making sense now. So in S dash, the T0 will be defined. What will T0, the proper time? Proper time is defined as the time that if an observer is in the same frame as the event, that is a proper time. So T0 will be defined again as y divided by VB dash. VB dash. This equation. Is that making sense? As seen from frame S dash. So T0 is a time for B, that B sees, that for B to move the round trip as seen from frame S dash.
यस मैम मैम जब हम फ्रेम एस में थे तब भी प्रॉपर टाइम ही यूज हो रहा था ना
फ्रेम एस में थे तो हम एक ही टाइम ए का टाइम मेजर कर रहे थे फॉर द राउंड ट्रिप दैट इज आल्सो प्रॉपर टाइम फॉर ए because A is in the frame S, तो जब हम S में बैठ रहे हैं frame में, observer is in S, so it will see A move with the proper time because A is in the frame S. Observer is in the same frame as the object. That will be the proper time. और अगर हम S dash में होंगे, अगर हम S dash में observer होगा, it's going to see the proper time for B because B is in the same frame as the observer. Does that make sense? ठीक है? But if the observer is in frame S and is observing B, फिर time dilate होगा ना? फिर तो because B को ऐसे देख रहे हैं हम. B is moving like this and like this as seen from an observer who is in S frame. So उस case में time dilation होगी. So T is a time. So if in S the speed VB is found from this equation, in S the speed VB time dilate हो जाएगा उस case में. ठीक है? So when we are viewing, when the observer is in frame S, that will observe a time T. ठीक है? And that will be y divided by VB. Y divided by VB. VB, where VB is the velocity that is observed of B, where VB is the velocity seen that is found from S frame. If you look from the S frame, then you will see that VB, the velocity of B is VB. Remember I said that B की velocity in S dash frame is given by VB dash, right? That's why VB dash हम use कर रहे हैं उसके proper time calculate करने के लिए. Yes?
मैम ये जो टाइम डायलेट हो रहा है ये किस फ्रेम में हो रहा है और किस ऑब्जर्वर के लिए हो रहा है?
Okay, I will tell you. So if we are sitting in frame S and we are trying to calculate the time for A to move this much and this much, that is known as a proper time for A's round trip because we are in the same frame as A. Okay? So if we are in S frame and A is also in the same frame, we will observe A to move up and down. And this is the equation for the proper time for this round trip of A. यहाँ तक समझ में आ गया?
Yes, ma'am.
Now, if we are sitting, observer is sitting in frame S dash, and it will observe B to move like this and like this. इसके लिए भी proper time होगा. Proper time हम कहेंगे T0 is equals to y divided by VB dash. Because why we can say this? Why we can say call both of them T0 because VB dash was equal to VA. दोनों हैं proper times. One is a proper time for B, one is a proper time for A. Because दोनों cases में for the proper time of A, we are sitting in this frame S, and when we are trying to get the proper time of B, we are sitting in frame S dash, which is the same frame as B. अब जब हम व्यू करेंगे B को इस फ्रेम से तो टाइम डायलेट हो जाएगा. अगर हम इस फ्रेम से A को देख रहे हैं तो टाइम डायलेट हो जाएगा.
मैम फ्रेम का नाम ले लें, वो लैग आ रहा है वीडियो में तो समझ नहीं आती.
Okay, so if we are, because A is originally in S frame, so if we're viewing, if an observer is in S frame, if the observer is in S frame and is observing A, then that will be the proper time. If the observer, because A is in S frame, if the observer is in S dash frame, तो फिर B को अगर हम view कर रहे हैं, that will be the proper, we will get the proper time. Because observer is in the same frame as B, which is S dash. ठीक है? और अगर observer opposite frame में है, observer is in S dash frame and is viewing A, which is in S frame, तब हम time dilation effect आएगा. Because हम opposite, हम दूसरे frame, which is moving relative to the other, relative to the frame that we are sitting in, that we will observe time dilation. Make sense?
Yes, ma'am. Thank you.
Okay. बाकी सबको समझ में आ रहा है?
Yes, ma'am.
Who was that? सबको समझ में आ रहा है? I hope everyone is understanding, because these are a bit difficult topics. Not very difficult, but you have to understand the situation carefully. So now if I talk about a situation where I'm saying that in S frame, now we are viewing from S frame से हम देख रहे हैं situation को, S frame से देख रहे हैं, and we're trying to understand what is the velocity of B as seen from S frame. We call that VB, because we know that VB dash, which is the velocity of B within its own frame S dash, that is equal to VA, which is the velocity of A within its own frame S. So we want to know what is the velocity. Why are we trying to find VB? Is because we want to relate the two momentums. We want to relate momentum PA. We want to find an equation for the relativistic momentum, and momentum depends on velocity. So we're trying to find how the velocity relates to the time, and then when we relate it to the time, we know the time dilation effect takes place. So because of the time dilation, I have to erase some part of this. This, because it's not going to, it's too messy here. So what I'm saying here is that VB is going to be equal to what? VB, the velocity of B as seen from frame S, is going to be Y divided by time. Is that making sense? T is the round trip time as measured for B to make its round trip as measured in S. Yes?
Yes, ma'am.
In S dash, however, B's trip requires the time T0. So we apply the time dilation formula. So T is related to T0 by this formula. The T, which is the time required for B to make its round trip as measured in S frame, will be what? Y will be this T is equal to T naught divided by 1 minus V squared over C squared, because of the time dilation factor. So when we do that, we, does this equation make sense? This equation makes sense? Okay, I think I should erase the board and write it all over again, because it's getting very messy. So, so we have, this is our S frame, and our A is in this frame, okay? A will move up and then it will move down, but this is our S dash frame. This is our S dash frame. So B is here, okay? B, and this is our A. B is going to move up and down. as seen from this frame. But as seen from A frame, because this is moving towards the right with velocity v, B is going to move like this and like this. But as seen from this frame, A will move like this and like this. Okay, A will move like this and B will move like this. यहाँ तक समझ में आ गया सबको? Okay, now we said that there are two equations we want where we're saying that VA equals VB dash because it's an elastic collision, okay? So our condition is that VA, which is the velocity of A as seen from S, this is what velocity? Anyone tell me? Someone has said something in the chat. Can you send the slide in the WhatsApp group? Sorry, ये कौन सा chat में आ रहा है? Okay, sorry. Okay, so what I'm saying here is that VA is equals to VB dash. ठीक है? What is VA? VA is the velocity with which A is going up and then coming back down. This is velocity of A, and velocity of B is the velocity. B dash is the velocity with which B particle is moving down and up in the frame S dash. Okay? So we have this condition. So we're saying that the proper time T0 will be equal to Y. This distance from particle A to the top of particle B from the beginning before they collided was Y. The distance between particle A and particle B, okay? The distance between particle A and particle B before they collided is Y. So we have Y divided by what? BA. Okay? Okay, and now our T0, if we are observing from frame S dash, that will be Y divided by VB dash. VB dash, yeah? Because it's the proper time. Proper time is when the observer is in the same frame as the object that's moving. So if the observer is in this frame, then it will observe this to move y distance with velocity VB dash. And when observer is in this frame, it will observe A to move with the velocity of VA in frame with velocity VA, it will move the distance y because this is half y and this is the other half of y. So y half plus half will give you 1. Half y plus half y will give you y. So these are two equations. These because we know that VA is equal to VB. So this obviously these two are equal. Because we know that VA is because this is our initial condition. So we know that these are equal. These two equations are equal. But now let's see a situation that we're sitting in this frame and we want to know, what is the velocity of VB as seen from frame S. Okay, this is velocity of B as seen from S. Seen from S frame. Does this make sense? As seen from S frame. This frame, as seen from this frame.
Excuse me, ma'am.
Yeah?
मैम ये बता दें ये जो इनिशियल कंडीशन यूज़ की है VA को इक्वल किया है VB डैश के, ये कैसे किया है?
ये इनिशियल कंडीशन हमें बताया गया है कि ये पार्टिकल्स दोनों उनके इनिशियल वेलोसिटीज ये थी, दोनों बराबर हैं. That's part of the question. Like the question says, the situation says that both of them are moving with the same velocity and the initial velocity दोनों का बराबर है. That's the question. That's what it's telling. ठीक है? So So yeah, we have the situation. Someone is saying something in the chat. Okay, well, I will answer that later. But what I'm saying here is that now we want to know what is the velocity of B as seen from frame S dash. So that is going to be equal to the time that will be y divided by t, which is a time which is dilated. We know that it will be time dilated, right? We know that because it's moving in this direction, we did this before in a previous example, that वो time dilate हो जाता है ना, because of its movement in this direction. So that will be y divided by, what is time? What is t? T is equals to gamma t0, right? Time dilation, हमारा result क्या था? T is equals to gamma t0. So it will be y divided by square root 1 minus b square over c square, yeah? And then t0 will be here as well. T0. ठीक है? So that's where we've got this equation. Sorry, wait. T is equals to gamma T0 is correct, but gamma T0, T is equals to gamma T0, and then when we put it in this equation, it will be reversed, sorry. Are you all following?
Yes, ma'am.
Yes.
Y is like this, ठीक है? T is gamma T0, so gamma का factor ऊपर आ गया, divided by T0. ठीक है? So this is our VB. Because of the time dilation effect as seen from this frame, B is going to be time dilated. So now we go back to our PowerPoint and we say we got this formula. ये भी हमने derive कर लिया, ये भी हमारे पास आ गया, ये भी हमारे पास आ गया. Now what we want to do is now we're saying from equation 1.11, where's 1.11? This equation, ठीक है? इससे हम क्या कर सकते हैं? If we use a classical definition of momentum, P is mv, then in frame S, what is the situation in frame S? We have mass of A times velocity of A. And I did not tell you in the beginning that the masses of the particles are equal. ये मैंने नहीं कहा शुरू में, ठीक है? So we want to relate the masses to each other, ठीक है? We want an equation that relates the masses as well. ठीक है? I did not say in the beginning that the masses are equal. They're not necessarily equal. So momentum of A as seen from frame S is MA times VA. So it will be MA, and we know that VA is given by this formula, which we already said before, so we just put it in here. So we get this equation for momentum as seen from frame S of A. Now momentum of B as seen from frame S will be MB VB, not VB dash. Why? Because we're talking about frame S only. We're not talking about S dash. Is that making sense?
Yes, ma'am.
So it will be MB VB, and because we derived VB over here, ये equation हम वापस इसमें डाल रहे हैं, यहाँ डाल रहे हैं ये equation. And now if we compare, because of we know that momentum will not be conserved where this is in masses. However, if this, the momentum will be conserved. So we want to conserve the momentum. We know that momentum must be conserved, ठीक है? Independent of the frame, momentum has to be conserved. So if we say that PA is equal to PP, y over T naught cancel हो गया, और ये हमारे पास equation आ गया. ठीक है? We're saying momentum is conserved because it's momentum is always conserved in any collision. So we will get this equation. ठीक है? यहाँ तक समझ में आ रहा है? So now after we get this equation, now we say, now we get the equation for relativistic momentum, because momentum P is equals to mv. ठीक है? So mv here we have MB is equals to MA divided by the gamma factor. So if I say that MB VB, momentum of B as seen from frame A, how will I, let me erase the board. Now if what do you mean by relativistic momentum? कौन से frame से हम किसको देख रहे हैं? From which frame are we observing? Now if I talk about A, which is in this frame, and its velocity is VA, ठीक है? And its mass is MA. What is the momentum of this particle? P will be equal to MA VA. Simple. Because this frame is not moving, we are the observers in the same frame as A. Yes? Now if I have a particle B here, and B is moving downwards with VB dash in this frame, VB dash in this frame, and it has mass MB. So what is its momentum in that frame? MPB. This is PA.
मैम ये PB नहीं होगा, PB dash होगा.
Yeah, PB dash. Okay, yeah. So here it will be MB VB dash. Yes. But what we want to find is we want to find the momentum PB हम find करना चाह रहे हैं ना, which is the momentum of B as seen from S frame. As seen from S frame. So that will be equal to gamma M. Gamma what will it be? MB VB dash. Yeah? This is making sense?
Yes, ma'am.
Because this was VB, MB is equals to MA over this. So MB is equals to MA over gamma. So this should be equal to what? MA, this will be equal to MAVA, right? Because I said that VB dash is equals to VA and MA is equals to gamma NB. So these are equal, and they have to be equal because of conservation of momentum. Okay? So as seen from this frame, as seen from S frame, B will be observed. We will have a momentum gamma and B VB dash. So that's how we've derived the equation. So we've derived the equation from relativistic momentum. And पहले जब हम शुरू कर रहे थे ये, पहले जब हम ये class शुरू कर रहे थे in the beginning of the semester, which was last week, I was starting off with the waves chapter, wave properties of particle, and I was telling you that P momentum is gamma and V. लेकिन उस वक्त हमने derive नहीं किया हुआ था, तो आप लोगों को सब किसी को इस वक्त समझ में नहीं आ रहा था कि ये कहाँ से आ रहा है equation. So does it make sense now कि ये कहाँ से आ रहा है? P is equals to gamma and V.
Yes, ma'am, it does.
Okay. So I want to tell you another thing, that M is the proper mass or rest mass. There's no, does it look like from this equation के mass relativistic हो रहा है? But there it looks like, क्योंकि हमने ये equation किया था ना, हमने ये equation derive किया था ना, तो ऐसे लग रहा है जैसे mass B relativistic हो सकता है. It looks like MB is equals to gamma MA. लेकिन ऐसे नहीं होता. We talk about the proper mass or rest mass of an object, ठीक है? We don't talk about there's no such thing as relativistic mass. Basically, Einstein ने कहा था कि relativistic mass is not good because no clear definition can be given for relativistic mass. We talk about rest mass, लेकिन हम इसको इस सेंस में इंटरप्रेट करते हैं, इस फॉर्मूला को इस सेंस में मोमेंटम के सेंस में हम इंटरप्रेट कर सकते हैं, लेकिन there's no such thing as relativistic mass. इसको इक्वेशन को हम ऐसे नहीं कह सकते कि gamma m is equals to ma is equals to gamma m dash, ऐसा नहीं कह सकते हम। सिर्फ इस इक्वेशन हम इसलिए ये डिराइव कर मोमेंटम को प्रूव करने के लिए, ठीक है।
मैम वैसे भी ये दोनों मैसेज डिफरेंट है, मतलब एम ए एम बी से डिफरेंट है। रिलेटिविस्टिक इफेक्ट में ये होता है कि टाइम वही होता है जो डायलेट हो रहा होता है।
So we will only talk about proper mass in this course, or rest mass, ठीक है। It will be considered relativistically invariant, ठीक है। So what I'm trying to say is that how does it go in the relativistic second law? F is equals to ma, हमें पता है कि F is the force is the rate of change of momentum, and if momentum is gamma and v, उसका derivative क्या होगा with respect to time? It's going to be more complicated now because gamma is also a function of v. So before there was no gamma. If gamma is 1, then we just have ma, because m is invariant. M is just, what do you mean by invariant? Means not varying, okay? Constant. So m is constant, it will go outside the derivative. We have just dv by dt, which is acceleration. But now this equation is going to be more complicated because gamma is a function of velocity. So what are we going to do now? We have an example here, okay? We will do this example. Did I have another example as well? Let me check. Relativistic second law. I thought I had another example, but anyway. Okay, so now what we are going to do is we want to try to find the derivative of gamma and v. तो ये आप सब आसानी से कर सकते हैं ना, इसमें कोई मुश्किल नहीं है। v divided by 1 square root 1 minus v square over c square. Basically, you will do this integration by parts, right? Not by parts, but by chain rule, product rule, okay? You would use the product rule here. So first you will do, I think you can all do this derivative, right? इसमें कोई explain करने की तो कोई ज़रूरत नहीं होगी, लेकिन first you will do the derivative of this part, which is 1, divided by this, so you will get this, plus then you put v, leave v here as it is, and you do the derivative of this, and you will get something like this, ठीक है? Into dv dt, because v can be a function of time as well, ठीक है? This will come in both this term and this term. तो फिर हम जब इसको open करेंगे, तो dv dt is just acceleration. We call it acceleration, and then we will get something like this, ठीक है? This term. So in this case, what do we see? Gamma is this factor. So basically, f is equals to ma divided by gamma cube. Sorry, multiplied by gamma cube. Because gamma is 1 over square root this thing, right? So we get gamma cube ma. What does this tell us? It's not gamma ma. So we cannot talk about relativistic mass. This is proof that we cannot talk about relativistic mass. Because if mass was relativistic, if according to our previous formula, according to the formula we got over here, mb is gamma ma. But we don't use that. We don't use that here. We don't use that. So it's proof that acceleration, F is mass is non-relativistic. We don't use gamma m for mass. ठीक है? In the classical formula. And if we rearrange this formula, you will get acceleration is equals to F over m times this factor. ठीक है? So this was just one example. So now I want to talk about mass and energy. And we want to talk about energy, and we want to prove the relativistic formula for energy now. Yeah? Time over हो गया, हम इतना थोड़ा सा करते हैं एक दिन में, इतना like time लगता है example करने में.
मैम अभी start है ना, तो
time is relative.
Time is what? Relative? What did you say?
Then time is relative.
Relative to what? Okay, well, हम बहुत थोड़ा अचीव करते हैं एक दिन में, because we are trying to understand.
अभी start है ना, तो अभी मतलब बेसिक्स बन रही हैं, तो फिर ऐसा ऐसा जब हम आगे तेज हो जाएंगे.
Okay, so we will start from this 28, slide number 28. And any questions so far? ये momentum, relativistic momentum की derivation में कोई question तो नहीं है किसी को? Who is 39? Registration number 39. Hello? Hello?
मैम सुमेर है
Chavo. He had in the chat he's written, can you send the slides? मैंने upload कर लिया है यहाँ पे files के section में, ठीक है? Files under class materials, ये सबको नजर आ रहा है ना? मैं जो खोल रही हूँ MS Teams पे.
जी मैम
तो यहाँ पे under class materials files के section में under class materials मैंने सारे slides upload किए हुए हैं, ठीक है? ठीक है? Okay, so any other questions?
मैम लाइट नहीं थी तो फिर मैंने मुझे ज्वाइन करने में मीटिंग ज्वाइन करने में थोड़ी लेट हो गया था मैं 3:20 पे ज्वाइन किया था तो फिर आप अटेंडेंस लगा दीजिए
Okay,
मैंने लाइव को बताया था कि वो लाइट नहीं है
yeah, मैं लगा दूंगी attendance, no problem. So, any other questions? Wait a minute, what is wrong with this? Okay, are there any other questions related to our topic for today?
मैम ये डेरिवेशन नीट मिल सकती है
Sorry, derivation?
नीट फॉर्म में आप ग्रुप में सेंड कर सकती हैं
This is a PowerPoint में already है, like इसमें extra चीज सारा calculation तो already हुआ हुआ है इसमें, लेकिन what basically do you want to know? Like इसमें सारे steps हुए हुए हैं. Basically इसमें बस एक चीज नहीं हुआ हुआ. I think the integral, the derivative. But this is an example. This is not part of the derivation.
सही है मैम थैंक यू
Because ये सारा तो already सब कुछ explain हुआ हुआ है इस PowerPoint में. It's already सब कुछ हुआ हुआ है. और ये भी like they've told you all the steps, so I don't think there's any need to send extra notes for this. ठीक है? Unless अगर कोई ऐसी derivation हो जिसमें steps ना दिए हुए हों, फिर मैं उस केस में आपको भेज दिया करूँगी. ठीक है?
यस मैम
Okay, ये सबको समझ में आ गया derivation और momentum किस तरह है?
यस मैम
Okay, so it's 3:51. If there are no questions, then I encourage all of you to ask questions. Let's can we start mass and energy or not?
मैम टाइम हो गया मैम तो काफ़ी टाइम हो गया
Okay, it's 3:51 only. 3:52. Okay, well, do you have another class at 4? No, I don't think so. I think it's the last class for the day. Okay,
मैम
मैम
ये
attendance.
एक्सक्यूज मी
Yes.
मैम ये क्लास की टाइमिंग शिफ्ट नहीं हो सकती इस टाइम बहुत लेजी हुए होते हैं कुछ सही से नहीं समझ
पता नहीं, because I have other classes during the daytime, like मेरे दूसरे classes भी होते हैं ना, तो I don't know how it's possible to shift it during the day. आपकी दूसरे classes भी तो होते होंगे ना morning में.
मैम किसी क्लास से एक्सचेंज करेंगे
दूसरे classes ज़्यादा like आसान है और मुश्किल और what? How are your other classes?
मैम अभी तो इंट्रोडक्टरी कोर्स ही पढ़ रहे हैं मतलब अभी तक तो ठीक जा रहा है आगे का नहीं पता
Let's see. I think this time is most suitable for me because I have other classes during the daytime, but I don't know. I will check if it's possible. ठीक है?
यस मैम थैंक यू
Okay, so yeah, if there's nothing else to discuss, then I will stop share, and I guess we can end the meeting now. If there are no other questions, ठीक है? Okay, Allah Hafiz everyone. We have class tomorrow at 3 o'clock as well.
अल्लाह हाफिज़ मैम
We will do energy and mass energy tomorrow. Yeah. Allah Hafiz.
अल्लाह हाफिज़
अल्लाह हाफ़िज़